In this video, I'll closely look into types of intermolecular force. Subscribe the channel, watch the video until the end. Intermolecular force, also called interparticle force. Intermolecular force, also known as non-covalent bond. Interparticle force can be attractive force or it can be repulsive force between neighboring molecules. We have 6 types of intermolecular force. 1. Dipole-dipole force. 2. Dipole-induced dipole force. 3. Dispersion or London force. 4. Ion-dipole force. 5. Ion-induced dipole force. 6. Hydrogen bonding. Relative strengths of the 6 types of intermolecular force in order of weakest to strongest is London force less than dipole-induced dipole less than ion-induced dipole less than dipole-dipole less than hydrogen bonding less than ion-dipole force. Dipole-dipole force, dipole-induced dipole force, dispersion force, collectively or commonly known as Van der Waals force. Now let us start with dipole-dipole force. Dipole-dipole force occurs between polar molecules. The molecule may be identical or the molecule may be different molecule. It doesn't matter. Now let us consider methanol. Methanol is polar molecule. Means that there is charge separation, there is uneven distribution of electron. In methanol, as we have seen, each hydrogen carries partially positive charge, but oxygen carries partially negative charge because oxygen is more electronegative than hydrogen. Because of this, it attracts the bonding electron towards its nucleus and it carries partially positive, whereas the rest atoms carry partially positive. Now consider the second molecule, ammonia. Ammonia is polar molecule and there is uneven distribution of electron in ammonia, means that there is charge separation. Therefore, nitrogen carries partially negative charge, whereas each 3 hydrogen atom carries partially positive charge, as you see. Because why nitrogen carry partially negative? Because it attracts the bonding electron toward its nucleus. Because of this, nitrogen carries partially negative charge, whereas the rest hydrogens carry partially positive charge. Now let us consider the second example, water. As we know, water is made from 2 hydrogen atom and 1 oxygen atom, and water is a polar molecule. Means that there is charge separation, there is uneven distribution of electrons. Because of this, each hydrogen in water carries partially positive charge, but oxygen carries partially negative charge because oxygen attracts the bonding electron towards its nucleus. Therefore, it carries partially negative charge, whereas hydrogen carries partially positive charge. Now, the other molecule here is bromomethane. Again, bromomethane is polar molecule. There is uneven distribution of electrons. There is charge separation. In bromomethane, each hydrogen carries partially positive charge, but bromines carry partially negative charge. And there is intermolecular force between methanol and ammonia by oxygen of methanol and hydrogen of ammonia. Again, there is intermolecular force between water and bromomethane. Water of hydrogen bonded with bromine of bromomethane by intermolecular force. Again, 2 HCl molecules form intermolecular force between them because HCl is a polar molecule. There is charge separation. There is charge separation, and the solid line here is covalent bond, and the broken line here is intermolecular force. The second type of intermolecular force is dipole-induced dipole force, which is formed when a polar molecule distorts the electron cloud of an nonpolar molecule. Now this one is a polar molecule. as you have seen here is there is a charge separation. The one is positive charge, the other is negative charge. There is two pole, positive pole and negative pole. But in polar molecule, there is no charge separation. Means that the electrons distribute evenly, and the shape of nonpolar molecule is a sphere. As I told you, there is no charge separation. There is no pole. There is no polarity in polar molecule. When this polar molecule distorts the shape of nonpolar molecule, the type of force formed is dipole-induced dipole. Look here. Initially, nonpolar molecule have sphere shape, but when we close these two molecules, that means polar molecule and nonpolar molecule, polar molecule distort the shape of nonpolar molecule, because in polar molecule there is charge separation, but there is no in nonpolar molecule. Now the polar molecule distorts the shape of nonpolar molecules. The third types of intermolecular forces, London force or dispersion force, formed due to uneven distribution of electron within a molecule, or it's formed because of the change in position of electron within a molecule, called dipole-induced dipole force. It occurs in both polar and nonpolar molecule, but it's mainly occurring in nonpolar molecule. Look this one. On the right side, there is symmetrical distribution of electrons, uniform distribution of electrons, even distribution of electrons. But when it comes to the right side, unsymmetrical distribution of electrons, uneven distribution of electrons. Therefore, there is polarity in the right side, but on the left side, there is no polarity. The fourth one, ion dipole force, formed when a compound dissolves in water. For example, sodium chloride dissolves in water by ion dipole force interaction. When sodium chloride dissolves in water, it broken into chloride ion and sodium ions. Look, as we know, water is polar molecules and there is charge separation in water. Hydrogen is positive charge and oxygen is negative charge. Therefore, chloride ion is attracted by positive charge of hydrogen, and the sodium ion is attracted by oxygen of waters, because oxygen of water is negatively charged. The fifth one is ion-induced dipole force. When ions charge distort the electron cloud of nonpolar molecules. This one is ion and this one is nonpolar molecule. As I told you, in nonpolar molecule, there is no charge separation, there is even distribution of electrons, and there is no polarity. But when these ion and nonpolar molecules far apart, there is no polarity in nonpolar molecule. But when the ions and the nonpolar molecule get closer, nonpolar molecule lose its shape. Its shape is changed into from sphere to oval shape. And here there is charge separation because of the polar molecule distort the electron cloud of nonpolar molecule. Now, nonpolar molecule, for a time being, it became what polar molecules for a short period of time. That's why it's partially positive, partially negative. Ions in hemoglobin to an oxygen molecule enter red blood cells is example of ion dipole force. The last one, hydrogen bonding, which is formed when hydrogen atom bonded with fluorine, oxygen, and nitrogen. For example, hydrogen fluoride has hydrogen bond, water has hydrogen bond, and nitrogen. Ammonia has hydrogen bond. In short, when hydrogen bond with three elements such as hydrogen, fluorine, oxygen, it forms hydrogen bond. In the first one, hydrogen bond formed between two water molecules. And in the second one, hydrogen bond also formed between two acetic acids. And the third one, hydrogen bond formed between